All right, so this is going to be the first section of trigonometry, which is 7.1. Bear with me on this. I realize that on your screen it's probably a little bit blurry. We're just going to have to deal with it. It is much clearer on your paper, of course. So just talking about this do now, this is going to be an introduction to what we're doing. It says, what units are used to measure angles? Well, for most of you, degrees are going to be what you are used to. Because that's what's most common. Okay, and again, I apologize if the writing is a little bit sloppy here, not really that big of a deal. But the other thing we're going to talk about here is, besides degrees, radians is our other way to measure angles. And this is going to be the new term, okay? So this is the new concept for you. And that's what we're going to be talking about a lot in this section and throughout trigonometry. So that's actually really important. So let's just talk about angles a little bit. The first thing that we want to understand, the history. These are all Greek terms here. We have alpha, beta, we have phi, and we have theta. What you need to understand is anytime you see these terms, it always means some type of angle measure. Okay, so angle measure. Whenever you see those, whether it be on a test, anywhere, it means that you're getting a measure of some type of angle. Okay, so you see alpha, you see beta, you see phi, you see theta, any of these symbols, it means we're going to have an angle measure there. So let's talk about angles. So right here we have a ray, and we have not created any type of angle yet. So this line right here, this is what we call our initial ray. Okay, so that's an initial ray. And then anytime that we create another angle, so another line coming off of this, and we can, obviously the angle could be anywhere, but we'll just, for purpose of what we're doing here, we'll create another line. That is called our terminal ray. In other words, that is where your angle is ending. And then the measure of that angle is going to be anywhere here. And like I said, that could be labeled with an alpha, a beta, a phi, or a theta. Okay, and triangles work the same way. We have angle measures, you know, just like we did in geometry. So those are all angles, and those can be measured most of the time in degrees. But when we're dealing with trig, they can be in radians as well. So initial ray, terminal ray. That's important. Wherever we start is our initial, and then where the angle is created is going to be our terminal ray. Okay. So let's go down to the next slide. Okay, the next slide is just you are familiar with what angles look like. All this is doing is showing you this is how we label an angle. It means that this angle right here is 27.8 degrees. Okay, so what does this mean? Well, how are we going to deal with this? Well, what we need to understand is that 27.8 degrees can also be written differently. So what I want you to think about is hours, minutes, and seconds. Degrees work the exact same way. Most of the time you'll see degrees written as a decimal, but it can also be written as degrees, minutes, and seconds. So think of it the same way as, like, if I told you that we were going to go 2.5 hours, and I want you to write that as minutes and seconds, I hope that you're not going to tell me that that's 2 hours and 50 minutes. And I think you kind of understand that. That 0.5 means half. So if we wanted to convert this, we would do 2.5. So we would say 2, and then what we're doing is we're adding, and we would have 0.5 times 60. And then what we'll do is we'll see if this gives us a whole number, which it does. It's 30. So that means we have 2 hours, and then we would have 30 minutes. And when we're dealing with degrees, minutes always has one little apostrophe, and then seconds always has 2 apostrophes. But the idea is we need to know how to convert. So that's what we do in this first one. It's the same idea. It's just that our whole number here is kind of like our hours, but that's really what our full degrees are. So we have 57 full degrees, and then we're going to convert the 0.2958 to minutes and seconds. So here's what we do. We do 57 plus, and what we do is we do 0.2958 times 60. And what we do is we see what that result is. So if I were to multiply that out, I actually get 17.748. Well, the problem is we still have a decimal. So we know we have 17 minutes. Okay, so I know that I have 57 degrees, 17 minutes, but now I got to figure out my seconds by doing 0.748. So it's going to be 0.748 times 60 again, because there's 60 seconds in 1 minute. Okay, and if you multiply that, you get 44.88. And now you can leave it as a decimal. Seconds can always be as decimals. So our answer then is 57 degrees, and then we say 17 minutes, and then 44.88 seconds. Okay? So now the second one, going back in the other direction, this is a little bit different, but not a ton. It's the same idea, except now we have to do a division. So here it's going to be 32 plus, and it will be 42 divided by 60, because that's the number of minutes there are in 1 degree. But here's where the difference is. For the last one, because it's 27 seconds, it's not going to be divided by 60. It can't be divided by 60 because there's not 60 seconds in 1 full degree. There's technically 60 seconds in 1 minute. So we have to do 60 times 60, which will be 3,600. Okay, so there's 3,600 seconds in 1 degree. 60 minutes in 1 degree. That's why the division turns out like that. Up here, we can say multiplied by 60 because that's what's left of your minutes. Okay, so this is how we set that up. You just simply put it into a calculator, and we get a decimal that says 32.7075. And that's what our degrees would be as a decimal. Okay, so let's move on. So next slide is talking about degree and radian conversions. Okay, so this is going to be a little bit different for you guys too. I think the good thing, a full circle will always have 360 degrees. So I think that's easy. Everyone knows that 360 degrees in a circle. Okay, so that means if you go all the way around, we have 360 degrees. When we're talking about radians, radians is a little bit different. As you've seen from before, or as you will see, radians deals a lot with pi. So radians, where it comes from is, if you recall how to find the circumference of a circle, circumference has always been equal to 2 times pi times r. And actually, what you see here with this 2 pi, that is how many radians there are in a full circle, is 2 pi. So 360 degrees is equal to 2 pi. It's the exact same thing. So what we have to do is we have to be able to actually convert between the two. So if I know that this angle right here is a certain degree, I should be able to convert that into radians. And then the same thing is true if it's radians, I should be able to convert it into degrees. So here is just some information for you. If you have 1 radian, that is equal to 180 divided by pi degrees. And again, if you wanted that as a decimal, that comes out as a decimal as being 57.2958 degrees. And then if we wanted to know 1 degree, the conversion, that is equal to pi over 180. Sorry about this writing. So pi over 180, okay, and that's radians. And again, we can put that into a calculator to get 0.0174533. And that's, again, radians. So we're going from degrees to radians, radians to degrees. Okay, so the idea here is that these are basically what our conversion rates are. If we want to go from degrees, or I'm sorry, if we want to go from radians to degrees, that is our conversion factor. In other words, that's what we're going to multiply by. If we're going from degrees to radians, we're going to multiply by pi over 180. So now here's what I want you to think about. This is why it's important, and I don't want you guys to get confused. If I were to divide this circle up, okay, most of you guys would realize that this right here. We're always starting, when we're dealing with degrees and radians, we talked about our initial ray. Our initial ray will always be here. It's always this horizontal ray right here. We always start from here, and our angles are always created starting from here. So you can see that this first degree right here, this would be 90 degrees. Okay? For when we're dealing with radians, it's the same thing as pi over 2. When we come over here, that's half of our circle. Again, that's pretty easy. That's 180 degrees, and our radians will be pi. Because if the full circle is 2 pi, then half the circle would be pi. And then down here is 270 degrees. And then our radians would be 3 pi over 2, which is 1.5 pi. So the way that I want you guys to think about it to make it easier for you is you want to look at it as, think of everything as pi. Everything is pi. Pi is 180 degrees. Pi is 180 degrees. Pi is 180 degrees. Because then when you convert, you can think of it as a fraction of 180 degrees. What do I mean by that? Well, let's look at the next slide and we'll see exactly how we're going to convert these. So I want to go from pi over 6, which is in radians, and I want to go 2 degrees. So if that's the case, this is the way I think of it. Because I know that pi is equal to 180 degrees, I think of this as a fraction of 180 degrees. So there's 2 ways we can look at this. We can look at it as the formula, which the formula tells us that we would do pi over 6 times 180 over pi, which is equal to, the pi's will cancel out, you'll see here. So pi cancels out, 180 divided by 6 is 30 degrees. That's easy. But if you don't remember the formula, if you forget which is on top, which is on bottom, think of this as, this is basically 1/6 of 180. Okay, the pi always goes away. If you're going from radians to degrees, the pi won't be there anymore. Okay, now sometimes the pi is not there to begin with, and that's okay, and then you need to use this formula that we're talking about right here. But the idea is you're thinking of this as 1/6 of 180 degrees, which is equal to 30. It's the same way of doing it. Okay, now down here, this is going in the other direction. I want you guys to, I think this is a little messed up here. We're crossing this out right here, and we want this to go from degrees to radians. Okay, so let's go from degrees to radians. And again, this is where the formula is a little bit more important. But again, because we're going from degrees to radians, the pi now has to be on top. Again, we're thinking of this degrees out of 180. Okay, that will turn it into a pi for us. So it's 28.277 times, wow, that is terrible. 28.277 times, and it's going to be pi over 180. So again, we want to know what fraction of 180 it is, and then the pi will be part of our answer. And again, you would just divide these two and either leave the pi in, or you can write it as a full decimal. So I did 28.277 divided by 180, and I got 0.157 pi. And then you can multiply that out if you want to and get just a pure decimal, which is 0.493 radians. And again, it is the same formula for each one of those. 180 over pi is multiplied when you're going to degrees, pi over 180. But again, I want you to try and have an understanding of where that comes from. So if you ever forget, you can still at least logic your way through it. Okay, last things that I want to talk about is coterminal angles, and then we'll be done. Coterminal angles are this. We talked about how an angle starts with this horizontal, and then it goes around a circle like this. A coterminal angle is what happens when you get back to the same place, because a circle obviously just keeps going around and around. So basically, if I wanted to know what a coterminal angle is, what I would do in degrees is I would either be adding 360 degrees, or I can be subtracting 360 degrees. So what does that mean? It means if I do 45 degrees plus 360, I get 405 degrees. That's coterminal. So if that's coterminal, it means they're the exact same angle. That's all it's saying. Okay, so you can either add or subtract. Okay, so what we're going to do is I'm running out of time on this video, so I want to finish this in class when you come in. We're going to finish the last 2 slides when you come into class. All right, so I'll see you then. Bring questions. Don't forget your quiz.